In this video, we're going to look at the Ceph storage system. The Ceph storage system is a cluster storage system. It is multi-purpose. A Ceph storage cluster, also known as RADOS, is spread out over a number of nodes, but it also makes available data in multiple forms. The first form is of object storage. Think of something like S3, where individual objects can simply be placed and retrieved from the storage cluster. Next, we have the block device export for virtual machines. Think of EBS on AWS. So using this system, virtual disks can be exported to individual virtual machines and you get them as Ceph block devices. So these are virtual disk images that can be mounted in a virtual machine and formatted with the file system and so on. Finally, Ceph storage cluster or RADOS supports the notion of a distributed file system. And this is through the Ceph file system. Here, you can actually access the data sitting on the Ceph storage cluster in the form of files and directories. So how does Ceph work? What is sort of the stack of software services that support Ceph? Well, it consists of multiple components. RADOS is the reliable autonomic distributed object storage service, and we'll look at that in detail very shortly. The library or API into RADOS is known as librados, and this allows direct access into RADOS from apps through a native API. Now, applications that don't compile or use librados can use any of the multiple higher level APIs. The first is RADOS GW or RADOS Gateway. This is a bucket-based REST gateway that's compatible with S3 and Swift. Then we have RBD or RADOS block device. This is a reliable and fully distributed block device. It contains a Linux kernel client and drivers for Xen, VMware, and KVM. So this allows you to export individual block devices that you can attach to virtual machines. And finally, we have CephFS, which is a distributed file system. But unlike HDFS or GFS, it's a POSIX compliant distributed file system, has a Linux kernel client and support for Fuse, so that it can be directly mounted into an operating system. Let's look at how RADOS works. Now, RADOS nodes are organized into a cluster, and applications that need to communicate with RADOS require either librados or some of the higher level APIs that you saw in the previous slide. A RADOS cluster consists of two types of nodes. One is the monitor nodes marked in M, and then we have nodes that run object storage daemons or OSDs. Now, this is only a logical view of the cluster. In fact, individual nodes can have multiple object storage daemons logically within a single physical server. Now, the cluster consists of multiple nodes in that fashion. And notice how we don't have just a single monitor node. We can have multiple monitor nodes, and they're organized in a peer-to-peer fashion for failover redundancy. Applications now can talk to the RADOS cluster using the librados API or any other higher level APIs to retrieve objects from the RADOS cluster. Now let's look at how data is placed in RADOS. Since RADOS is a system that is truly distributed without a master-slave architecture, in fact the nodes are all organized in peer-to-peer architecture, any single object that is denoted by a certain key needs to be located into a specific object storage daemon. In RADOS, we have an example here. We have a certain object with certain binary content, and the name of the object or the key of the object is foo. The key is hashed using some hash function, which will provide it some kind of placement group. In this example, we get the placement group number 23. Now, the placement group is translated to a bunch of target OSDs using an algorithm specific to Ceph known as the crush algorithm. The details of the algorithm are beyond the scope of this video, but basically once a key is hashed and the hash value or the placement group is obtained, then using this specific algorithm, you can find the target OSDs for a particular node. In this example, 24 is the primary target OSD for this particular key, and 11 and 13 are the replicas or backups. Finally, we'll look at some of the modes at which RADOS supports replication in the cluster. There are three main methods that RADOS uses to replicate data in the cluster. The first idea is of primary copy replication. So if you look at the image here, we have the client and we have the individual object storage daemons 1 through 4, and they are indicated on different parts of the x-axis, and the x-axis essentially represents the flow of messages, while the y-axis denotes the amount of time or the amount of network hops that takes to respond to a request. In primary copy replication, the client will send the object to the first object storage daemon, OSD. That takes 1 hop. That object storage daemon will forward that block for writing at the other object storage daemons. Notice that the first object storage daemon did not write the file yet. In fact, it is on a delayed write. And by delayed write means that it will not acknowledge the writing of that particular block until some condition. And the condition will be explained right now. The other OSDs will apply their writes and respond back, and that takes a total of 2 hops. Once the primary copy of the replica hears back from all the other OSDs, then it can also apply its write and then respond back to the client. So that's a write operation. In this primary copy of replication scheme, reads can happen basically at the first OSD itself. Now, in chain replication, the client sends the individual blocks to the OSDs in a chained fashion. So the first OSD to receive it will write it and then forward to the second OSD and write it, and then the third OSD and write it. If you may recall, this is exactly the same as how HDFS replicates data in this pipeline fashion or chain fashion. Notice that it takes n plus 1 hops for a write operation to complete, and the write is always acknowledged by the last OSD in the chain. However, reads can happen literally in 1 hop. The reads will go to the last OSD in the chain, always in chain replication. Finally, we have splay replication. In splay replication, it's kind of a hybrid between primary copy and chain. Writes still take about 4 hops, but reads can complete it in 1 hop. The first OSD to receive a write request applies it and then forwards the request to all the other OSDs to apply immediately, except for the last OSD. The last OSD will also receive the write request, but it will be a delayed write request. The last OSD will complete the write only after hearing from the other replicas and then acknowledge the write to the client. So a write still takes about 4 hops, but a read can be completed in a single hop using the splay replication scheme.